right, I'm going to talk to you about doing everything twice and trying to be faster at it. The general gist of it is that we create our entire game in C# first, and then we convert everything to C++, and then we ship it. So before that, though, it probably doesn't make sense right now, but so I'll give you a little bit of history. I'm the second Dutch guy on stage here. Woo! We're taking over. I'm from the land of Holland, the Netherlands, whatever you want to call it. We call it Nederland. Everybody lives in a windmill there, and everybody wears wooden shoes. So just so you know, Rami can probably attest to that. This is a computer I started to learn programming on. I taught myself to program on a C64, the most fantastic home computer ever built, in my opinion. Wait, is there actually, sorry. I don't see the presenter notes. There we go. That's better. So yeah, I taught myself to program probably around age 6 or 7. I don't quite remember. It's so long ago. I'm so old right now. But oddly enough, there was no game programming, no game design school anywhere. So I studied mechanical engineering, which is a little odd. But after I was finished, I knew what I wanted to do, and that's definitely not mechanical engineering. I wanted to make games. So I started work after university was done at a company called Lost Boys Games. This company later merged or converted into Guerrilla Games, which you might know from Killzone. I didn't actually work on Killzone. I worked on a project that wasn't ever actually released. I worked there for about 3 years, and then I decided to look elsewhere. Now, unfortunately, this was the only company in Holland that was really around. Oh, there were a few other ones, but I had my mind set to go elsewhere. So I applied at Relic, right here in town, and packed my bags. Well, they gave me a job offer first, of course. Packed my bags and moved here. So I worked there for about 5 years. I finished 4 games: Homeworld 2, Dawn of War, The Outfit, and Dawn of War Dark Crusade. Now, these games are all fantastic to work on, but there was one thing I noticed. So my AAA experience really was, every time we were working on a game, we were working with the giant monolithic C++ engine, often with pretty bad tools. And the code was shared between the editor and the game. So there's if-def editor everywhere. If you know how to program, that will make sense to you. Basically, the code is all interconnected. There's lots of dependencies between stuff. We wanted to create a texture converter just to convert a texture from a PNG to our own format. And we had to link in the sound system and the localization system. That doesn't make any sense, right? So load times were another big problem. Like, a lot of the games we worked on literally didn't start loading in less than 2 minutes, like 2 months before shipping, which just doesn't make any sense because you can't iterate. Like, imagine changing a little thing and then having to reload the game for 2 minutes before you can actually see it. So often the actual schedule, the time schedule that we saw in those games went something like this. So first of all, this is set ship date. This is what Shane was talking about too. It's like set ship date, and we're going. And obviously this line is not really progressing fast enough because there isn't real time for iteration. You just need to get the game done. So everybody's like frantically working. So progress is slower than expected, and some suit somewhere will at one point go, oh shit, this is never going to finish on time. So what happens? Well, first of all, the ship date gets pushed forward. Then the whip comes out. People do overtime. More people get put on the project, and usually the game ships when it's about 90% complete, which, you know, I would think is a problem. But apparently it's not, because there's always the day 0 patch. Woohoo! So a few poor souls remain behind while everybody else goes on vacation because the game is shipped, right? And brings the game to 100%. So I've done this a few times at projects that I worked on, but I always thought, like, man, there has to be a way to do this better, right? So right around this time, I got a call from Jamie Chang at Clay, and he said, so I have this project. It's a pretty cool project. It's a group or a company from Toronto called MetaNet. They have this game, and they want to put it on Xbox Live Arcade. The problem is I don't have time to do it. So if you can do it for me, that'd be great. Why don't you start your own company? So I thought about that for about a millisecond and started my own company. So this is where I went from working overtime to working all the time. So this was 2007. We started Slick Entertainment. I wanted to use a completely different methodology that I had been working in AAA. So we created a number of games with this methodology, N+, which was the MetaNet game, for Xbox Live Arcade, by the way, not for the other platforms. We did Scrap Metal for Xbox Live Arcade and iOS. Then we did Shellraiser for iOS and Android. And now we're working on this game called Viking Squad. Woohoo! Which apparently I have to work on for the elevator pitch a little bit. Rami, thanks. So currently, Slick Entertainment is 3 guys. It's Jesse right there. He does all the art. Say who, Jesse? Come on. Okay, terrible. And Kaylee is sitting two seats over. He does the design and helps me program the game itself. So basically what I started, when I started Slick, the different methodology that I wanted to use is to change this graph, the AAA graph, into this beautiful green indie graph. Woo. So how do I do that? Like, how do I get the progress of the game to go quick in the beginning and sort of taper off towards the end, rather than trying to pull the plane up to ship it on time? So I see 2 big phases in game development. First of all, prototype and editor. So this is the first part, and you get to about 80% complete, or that's what you hope anyway, by creating the prototype and the editor, and by that time you have the editor functioning well enough so that the content can be created for the rest of the last 10%, which always takes 90% of the time, right? So when I say prototype here, I don't just mean a gameplay prototype that proves the game. Also, very important, for my job anyway, I'm the programmer, I like to prototype the actual game code architecture, because that changes around a lot. Like when we go, hey, let's put this in, it might completely change the architecture for the game. So prototype here is everything. So after this, we come to the polish and filing phase. So this is where you fix bugs, you make everything run smoothly. We do create a lot of content in this phase too, because the editor's ready. You just go and make more content. So you're getting the game actually ready for a release. So I often refer to the first part, the prototype and editor part, to building the wood framework, and then the polish and filing phase is like pouring the concrete. Because in the polish and filing phase, it's really hard to change anything in your game, right? Because you're going for the goal. So looking at these 2 big areas, what do I actually want as a developer in those areas? So the prototype and editor, what I want flexible code. I want to be able to move stuff around. I want to be able to throw stuff out, put new stuff in. I want an easy-to-use UI system. I want to be able to quickly make high-quality tools that anybody can really use. So anybody who's used Windows knows what a combo box is, like the little thing with the little arrow next to it that shows you a bunch of choices. It would be really nice if there's no learning curve on how to use all this stuff. And I want garbage collection. Garbage collection, I could probably talk about an hour on garbage collection alone, but in an editor, I do want garbage collection because it's just easier, it's quicker, it's less prone to crashing. It's just very handy in an editor environment. So what do I want for the game? I want it to be bloody fast. I want it to fast loading, and 2 exclamation points for the sole reason that there's still loading screens in games. What the hell, guys? Come on. There's hard disks, there's SSD drives. It's fast to load stuff. It really is. If you do it the right way, you can load stuff really, really fast. And I want clean and portable code. Obviously. I don't want any editor code in my final game. So what's the best tool for the job? Now, obviously, this depends a little bit on your personal preference. I prefer C# and .NET for the prototype and editor. C# is very flexible, very quick to use. It has a lot of really cool tools in Visual Studio to rename variables, reorder them, move entire parts of the code into a function, et cetera, et cetera. It has an easy-to-use UI system. It's the Windows Form system, which basically a lot of Windows, the Windows programs they ship are built with this. It's very handy, very quick to put together. And the syntax is actually fairly similar to C++, which is my choice for the final game. Now, not everybody likes doing everything in C++. I like it. I'm used to it. It's very, very, very quick. It's very portable. It compiles even on washing machines, apparently. You can actually load stuff really fast. I'll get to that a little bit later. I prefer not to have garbage collection in my game for the sole reason that garbage collection is unpredictable, or can be unpredictable, if you use it the wrong way, or you have a large game with lots of active objects. And it can just stop your game for 2 frames, which I don't like. So this is the editor that we use. I basically built a framework for this editor, and I reuse it every game. So every game we do, the little tabs at the top there, a few of them are actually shared, so they go from one game to the other. And a few of them are specifically built for the game that we're working on. So this is the one for Viking Squad. This is the entity editor. This is where you set all the variables for the characters that will spawn in your world. This is the procedural step. So we have this procedurally generated backgrounds system where on the right here you can kind of see that tree view. This is where you say, okay, every 2 meters I want a tree, but I want it offset randomly, or I want to select a stone or a tree or stuff like that. So this one and the previous one are actually tabs that are made specifically for this game. This is a visual effects tab, so this one is shared between projects because every game has visual effects. You can add particles, sunbeams, all that stuff. Test them right there. The next one is our puppet editor. So this is where Jesse spends most of his time. He'll import all the little parts for the character, put it all together, put some skeleton in there, and animate it. Now, if you guys know Spine, it looks remarkably similar. I don't know how that happened. But you can also hook up sounds, visual effects, camera shakes, all in the animation. So whenever the character's walking around and does a big jump and lands on the floor, the camera shake is hooked up in the animation, so the screen starts shaking when you're playing the game. So this is a separate tab that Kaylee requested, basically. He needed a quick way to test fighting enemies. And that's what our game is about. You're a Viking, you're smashing enemies constantly. So besides that, he wanted a quick way to tune them as well. So we made this little thing called a dojo. It's just a little piece of land. He can spawn enemies. He can, tune the enemy right away, and you see the result right away as well. So when you're fighting, oh, this guy needs a little bit more health. He has more health, and go. You're good to go. And the last one, this is actually probably the most important one. This is the actual prototype that I would call prototype. This is the entire game running in a tab. We have debug stuff on the right, so you can print out things of what's going on in the game. But this actually has the entire UI flow of the shipped game in it. So including all it even runs multiplayer. You can connect to a different computer and play it against each other. So the editor spits out a bunch of data and reads from that data. Now, that data and content are things like PNGs, WAV files, binary data, XML files, shaders, all that stuff. But preferably, obviously, we don't want to redo all that for the C++ version. So we reuse it. But we don't reuse it right away, because the game, I don't want to load a PNG file and convert it to a texture. I want it to be ready cut for the game to consume and just go straight into the graphics card. So we have a make archive. Make archive is just a little tool that does things like it resizes textures, it combines a bunch of textures into texture atlases, it precompiles shaders, removes all editor data, and then packs it up into one giant file, and that file gets read in the C++ game with the best kept secret in C++ game programming, the memory map file I/O. If you don't know about this, check out the dev blog. I've done a talk or a dev blog about it that explains why it's so freaking awesome. It's really, really fast. So C++ only loads this completely optimized data. And then what we ship is only the bottom 2 parts. So that's data. But how do you share the code? This, of course, is the big question. So we don't actually do everything twice all the time. Only 25%, roughly, is actual game code. 75% are reusable libraries that we've used over time, over all the games that we've made. So we can save a lot of time because the 75% of libraries are already converted to C++, and we just use it again the next time. So if you can this is a C# screenshot from Visual Studio from the render engine, and then there's a C++ render engine. There's the same directory structure. There's a few different ones like the PCH and the properties and references on C#. But there's the same name for classes, the same variables. Literally, if you put the C# and the C++ file together, they have the same look. It's just a different language. So the C# code, the only difference there, of course, is that we stripped out all the saving code because we don't need to save anything, well, other than game progress, but you don't need to save an entity structure. And so we're only left with loading code, and all the editor code is gone. So it's really lean and mean. And revision history is your friend. Very important. If you change anything in C#, because you want to keep them in sync, right? The C# version and the C++ version. Just look at the revision history. It lists everything you've done or everything anybody else has done. And then you just go through it and convert it over to C++. So a few conversion tips. I don't know how many people here actually were programming in C++. Oh yeah, right on. It's not as bad as I thought it would be. So a few things. If you do have C# code that you want to convert to C++, use SDL. SDL is very good. It's very fast. A lot of people seem to not like it. At least when I was in AAA, people were like, ooh, SDL bad. No, it's not. It's really good. Dictionary map straight to standard map, list straight to standard vector, standard list, depending on how you want to use it. So read up on that. I only use C# delegates and reflection, which are very powerful tools. I only use it in editor code, because the equivalent in C++ is actually kind of shitty. The delegates, where you can do callbacks. Reflection, well, that requires a whole bunch of other stuff. Beware of value and reference types in C#. So C# has a different way of passing things around, or not entirely different, but it's important to notice the difference. So a reference type would be kind of like a pointer type in C++. A value type is just passing something by value, but be aware of which classes are variable or value types and which ones are reference types. And also be aware C# destructors are not equal to C++ destructors. C++ destructors get called right when you call delete. C# destructors, who knows when they get called? It's up to the garbage collector, which is why I love that thing. So a few prototypes we've made with this engine, just to show you that the 75% of shared libraries actually expands. It's slowly going to like 80, 85%. This is a prototype we made. It's Planet Strategy, we call it. It's sort of an advanced version on a hex-based planet. So for this, we had a custom mesh generation code that we added for this that we actually using right now for the procedural stuff. Then we have Star Razor, which was like a fun pun on Shellraiser, of course. It was you're flying a spaceship fleet through a bunch of caves, and you collect loot, et cetera, et cetera. So we used a lot of post-processing in this, like line of sight and all that stuff, and that's what we're still using right now. Then we have this one that's a turn-based brawling game, which is kind of the precursor for Viking Squad right now. There's even a Viking in the middle there. And then we have the last one. It was called Witched City. So this one was actually interesting because it used a lot of procedural generation of the entire world, which is also turned out quite slow, which is one of the reasons we kind of abandoned that one. But the procedural generation of the trees and stuff, that's basically a carbon copy of what we're using now for the procedural lanes. So what do we get from this method? I think we get very fast iteration, and we get very efficient tools. The code reuse between projects is actually higher than I've ever seen at Relic or at Guerrilla Games. So that really helps us out as well. And we get a smooth end product, which is the most important part, because that's what you ship, with fast loading and no garbage collection. Yes! And that's it.